Video lesson 10.7. Today we're going to find the volume of a pyramid. So first things first, the pyramid, the figure itself, does have an opportunity to have different types of pyramids. It's all based on the base portion of it. So when we're looking at the pyramid, it's important to notice what the base is. And then you can see as they all come to the same point, all of these sides are going to be these triangles for each one of the sides. Notice the formula is 1/3 big B times H, right? As we discussed before, big B, right, is your base area, right? Just like here, that's your base area. So again, that's because each of these pyramids could have a different base. We could have a square base, which is what this diagram is. You could have a rectangular base. You could have a triangular base. You can even have like a pentagonal base too, or something like that. But they can change. So you want to be able to find the area of whatever that base is going to be. So that's this way. And like I said, for this diagram, I'm going to call this a square base. So we're going to say that like all these sides are congruent. The height is normal, right? That's the same thing we've done before. So in this case, here's my height. Okay, the altitude, that's going to make a right angle with the base. And the other part that's we talked briefly about with a cone, and that's the slant height. That's this one here, right? And again, that's a realistic value that you could probably get if you're thinking about it. Like just think about like a real pyramid. Like it might be difficult to actually find the height this way, but we could calculate maybe the length up one of the outsides of the pyramid from the base to the top. Notice that when you do that, this is again a height of the side, so it would be perpendicular with the base, right? So we might be able to use the slant height to kind of find what the actual height is, or sometimes it might be the distance down here too as well. But we'll kind of work through those. So for this example here, it says an edge or the side length, which is just 10, a height which is 12, and the slant height is 13. So if we're looking for the volume, right here, we've got enough information to find the base area and the height. So the slant height's not necessary for this one, but let's just find the area of the base first. So that's going to be, in this case, side squared because it's a square. So that's going to be 10 squared, which is 100. Right, so that's my base area. So if I plug that into my formula, I get 1/3. We're going to plug it in 100 for the base area. And the height in this example is, what did you say, 12? So now I can simply multiply. All right, it's all multiplication here. Again, I would recommend making your life easier. So like 1/3 of 12 is 4. So that just becomes 4 times 100. Which is 400, and again, units cubed. In this case, we don't actually have specific units, so just units cubed. So that's the process. Again, it can get a little trickier sometimes depending on the information given to you, but that's the overall concept. Formula is not much different than things we've done in the past, so hopefully this one isn't too bad. So looking at example number 2, so the Great Pyramid of Giza in Egypt has a square base that measures 760 feet on a side and a height of 481 feet tall. To the nearest tenth of a cubic foot, find the volume of the Great Pyramid. So again, just going to use our volume formula. So V equals 1/3 big B times H. In this case here, my base area is a square. So that's going to be side squared. So that's be 756 squared. So if I plug that into the calculator, I get 756 squared. 571, 536. All right, so that's what I'm going to be plugging in for my base area. So if we go back, I got 1/3 times that number. And what was my height? My height in this case was 481. That's this piece right here. All right, so it's 481. All right, so this is going to be a big number, but let's plug this into the calculator, see what we get. All right, so I've already got that first number, so I'm going to multiply that by 481. And multiplying by a third or dividing by 3, same thing. So in this case, I get a volume of 9,163,000. What was it? 1,636,272. So that was a little sloppy. 6,272. So that's there. So 91,636,272, and this is feet cubed. So that would be the answer in this question. Now, just to kind of keep some information in the back of your head, is that really a good unit of measure for this? No, right? Feet would kind of be, for something this large, feet's a little too small of a unit. So this is an example of where, maybe having a conversion might make this a more realistic or a better option. Maybe they give you, the information is like one of them in feet and another one in meters or something like that. Again, if the units of measure are not all the same, you do need to convert to get them to be all the same. All right. So like I could convert this to meters. There's 3.3 meters, 3.3 feet in a meter, or I could do yards where there's 3 yards in a foot, 3 feet in a yard. Sorry. I can convert it to miles. Like I could do a whole lot of different things if needed. So keep that in the back of your mind. But again, all the units would have to be the same when doing it. All right. Example number 3. Find the length of the slant height along the shortest edge. So I want to come from the top down to the shortest edge. So in this picture, the short side is the 5 mile side. So we want to find from here down to there. So we're looking for this line here. And again, it has to be perpendicular to the base. Then so we've got our height here. And then I can find this distance right here. As well. So from the point where it touches the side to the center where the height comes down to the base. So we've got this orange side, we've got the height, right? We do know that the overall length of the side here is 8. So if this height would be directly in the center, so this means this purple line here is half the length of this. So if this is 8, that makes this 4. And now we've got 2 sides of our right triangle, which allows us to find the slant height. So in this case, I'm just going to call this x, right? So now I can go and use my formula, a squared plus b squared equals c squared, right? Again, whenever I'm looking for whenever I have 2 sides of a right triangle, I'm looking for the third, I can use Pythagorean Theorem. So a and b are my legs. So in this case, one of my legs is 4. The other leg is 8. And we are looking for our slant height, which I called x. And again, these are all squared. So if we simplify this, I get 16 plus 64 is equal to x squared. This is going to get me 80 is equal to x squared. So if I take the square root of both sides, I get x is equal to the square root of 80. Not a perfect square, but I can simplify that. That would be radical 16 times radical 5, which would be, this is a perfect square, so I get 4 rad 5. Again, it did not ask me to round here, so I would leave it in this format, right? This is, our unit of measure here is miles, right? So it's 4 rad 5 miles. And just to make sure that makes logical sense, if I plug that in, right, 4 rad 5, and hit enter, it's approximately 8.9 miles. And again, so I just look at the context of my question, and that does make sense, right? This length has got to be longer than the height, right? So that does make sense. So if it asked you to round, you could have, but in this case, it did not. All right. Last but not least. Oh, and obviously, you could be given the slant height and have to find, the height in order to find the volume or something like that. So that's, again, a little bit more realistic, but I just wanted to kind of show the process, with the slant height part. All right, last one. A little trickier one here. So we've got a pyramid that is constructed from a cube as shown. So they've taken this cube, they've connected these points to create a pyramid-like shape here. So it does come from here. So first thing is we've got a cube. It's inside of a cube. The second thing that's important here is that point C is a midpoint of the edge of AB. So this spot right here, that's a midpoint. So that's going to be helpful for us to know. The other thing is that we have the volume of the cube for here. So in order for me to find the volume of this shaded region, aka the pyramid here, I would need to figure out some side lengths, because right now I don't have anything. So the only thing we know for a fact at the moment is that whatever AB is, right, AC is going to be half of that, because C is a midpoint. So let's kind of work backwards first. Let's find the sides, because so I have a cube. So the volume of the cube, right, is equal to side times side times side, or side cubed, or you could use edge. Some formulas use E for edge. So we've got 216 is equal to S to the third. Again, to undo a cubed root, I'm going to take the power of 3. I'm going to take a cubed root of it. So use your radical symbol with a little 3 and the check mark. All right, that's going to undo the cubed part. So S equals, now if you're in your calculator, if you don't know, if you go into math, option 4, all right, there's your cubed root button. So we're doing the cubed root of 216. Let's hit enter, and I get 6 as my answer. So the side length is 6. So this is 6. All right, this is 6, this is 6, right? All of the lengths of are 6 because it's a cube. So that makes this one here, right? In this case, AC, that's 3. All right. So for the volume, right? For the volume of the pyramid, 1/3 big B times H. So we're looking for big B. So big B, in this case here, I'm going to draw it here, right? That's the area of the base, is a triangle. So we've got that to be 1/2 base times height. Now again, remember the height and the base, these are different ones. These are different bases and heights because we're referring to a different figure. So I've got a base here. Now this is a cube, so I know that this is a right angle here. So that's my base, which would mean this is my height of the base, which is also 6. So now I can say that 1/2 base of 3, height of 6, that's going to get me 9. So I can now plug into my formula here. I've got 1/3, base area is 9, and the height of the pyramid in this case here is 6. So I've got 6 for that value there. And once I have that, again, this becomes a lot simpler. Just kind of plug it in and go from here. So I get a grand total, what is that, 18? 18, and we have units. So this was centimeters cubed, so that makes this centimeters. So that makes this centimeters cubed as well. All right. So again, that's where they can give you alternate information. You have to kind of work backwards to be able to find the information that you need in order to find the volume. So this is again a common thing that occurs with volume questions. Not always just so straightforward. Sometimes you got to work around to try and get some information first. And then allow that to actually find the volume. And as we've also seen, they could ask density questions as part of this. Determine the weight or the density of something. Using it, remember, just as in the back of your minds, if you are just trying to remember, density equals mass over volume, right? So as long as you've got 2 out of those 3 things, you can always find one of the other pieces. Okay. All right, so take the opportunity, to review the notes here, the video notes, and don't forget to utilize the practice problems for more understanding.